We are going to discuss kth smallest in binary search tree. Basically what we have a binary search tree. If you don't know what is a binary search tree, for the root, all the values on the left hand side of the root is always smaller than the root value, and on the right the value is greater than the root value. And this is true for all the subtrees in the given tree. Like if you check this, this is your root. Let us suppose if this is your root, the value on the left hand side, so like if we have any value, it can be less than 1, it can be 0 or minus 1 or something. And as you can see, value on the right hand side is 2, which is greater than the 1. So let me just revert back to the given question, and you have given a value k equals to, let us suppose, 2. So you have to return the second smallest value in the whole binary search tree. Question is pretty simple. Like you just have a binary tree, you have to return the kth smallest value. Like if second smallest value, we talk about the values in this binary search tree are 1, 2, 3, 4. The second smallest value is 2. If we talk the first smallest value, it can be 1. So on. So now you know what we have to do. Basically, question is how to do. The most simplest and brute force approach is create a vector or any container. Wait a second. Create a container. This is not working. So create a container, and you can put all the values like 1, 2, 3, 4 and sort them like 1, 2, 3, 4. And if it is asked k equals to 2, second smallest value, you can simply do, like if this is your temp vector or temp list, you can simply return temp k minus 1. This will work, but the thing is, the space complexity of this problem will be big O of n, and the time complexity will be big O of n to traverse, big O of n log n. There's some issue, I guess. What you can do, if you know a property of a binary search tree, like if you do a in order traversal of a binary search tree, you will get the values in the sorted or in the ascending order. So like if I want to do in order traversal, and let me just tell you what is in order. In order is when we go left, then we choose that node, like or you can say we check that node, then we go right. So like if we are standing at this node, first what we'll do, we'll go left. Like we came here, so this is our node. So what we want to go left. Left is null, we don't want to do anything. So like if I create an array, left gave you nothing, you came back, you printed or like you checked the null node, like you did left, now node. So like you can push it in a vector, simple. Then you can go at the right, so 2, left is done, node is done, right is done, you will go back to the its parent. So like for this, if this is your root, left is done, so then you have to check this node, 3, left is done and the node is done, and you go for the right, which is 4. Simple as that. Okay, and then as you can see, this is sorted, and what you can do, simply you can return the k minus 1 position. Like if k is equals to 2, second smallest, simply you can return vector name temp k minus 1. So now you don't need to sort, and n log n of time complexity is reduced. But what about space complexity? Space complexity is still big O of n, as you may have to, or you can see, still you are storing all the values in the vector. And to remove that, just think how to remove the space complexity, like how to optimize the space. Like we know at the left and the deepest node, your value will be like that will be your first value or the smallest value. Okay, like if we came here at the left subtree, this will be your the smallest value, this can be your second smallest, then third and fourth smallest. If we can mark somehow, or if we can track uh, the value that it is a first value, it is a second value, it is the kth value. So simply what we can do, simply if we can count, so just simply we can have like in order, we were having 1 2 3 4, okay, and we know this is the first smallest value, this is the second smallest, third smallest and the fourth smallest. Somehow just we don't want to just store these values in our array, and we just want to have the count, and whenever our count or the number reaches k, we want to just return that value. So let me just write a pseudocode. I'll write in order here. Okay, left, root, right, or we can say left node and right. So if you can just track the number of node you have visited, so like I'm just simply writing a function and I'm passing the root, and for in order traversal, you know, left node and right. So if left exists, if you have a left, basically what you want to go to the left, okay, f root arrow left, okay. So like you came here, and for this, if you again go, you want to go left, so left doesn't exist, you came back here. As soon as you came back at the first node, you want to know this is your first node that you are visiting, or this is your second node, this is the third, and so on and on. So like instead of pushing it in a vector, I can increase its count or count visit, whatever you want to say, and it will be initialized as 0 in the main, and I can pass it as a variable here. Oh sorry, pass it as a parameter, and here also. If you are not understanding, I'll explain it again. If root right is there, what we want to go to the right, and when we go to the right, we know we'll go left, it won't give anything, we'll come back, and when we are marking this node, we will increase its count, okay. And before like going to the right, do you think we should check if before like going at the right, when we mark this is the first node, we should check if this is our desired node or not. So instead of checking at the right, we'll check if count, okay, if count double equals to k, we'll simply return, or we can say val, we can put it somewhere, so I'll say answer equals to root arrow val, okay. And the next, what we want, we'll want to go to the right, so if right exists, if your right exists, what we want to go to the right, I hope this is readable. And for the base case, if root is null, root double equals to null, we'll simply return. So if you don't understand, let me explain again. First we are here, we will go left, we are standing here, so this is our root node, okay, or rather let me use different marker so you can see it more clearly. We are standing at the one, this is our root node, are still count equals to 0. Let me just write it here, count equals to 0. Okay, and for 1 we went left is not there, so we came back. Like with this block, if block won't work, so we'll increase count, because this is your first node you traversed here, and count will change to 1. Okay, count is in now 1, and we are checking if k count equals to k. Count is the count is the smallest value that we have to return, or the k is smallest value. For example, k was equals to 2, which means second smallest value. Okay, no, it's not equal. We'll go to the right. While coming right, now this is your root. This is your new root. Okay, for this we will go left. Left is null. We'll come back. Then marking this, so you'll increase count. Count will change to 2. And before going to the right hand side, we'll check if count is equals to k. 2 is equals to k, which is also 2. 2 is equals to 2, which means yes, this is our the second smallest value, and we can have this in our answer, and we can return it from here also if you want, and just this will be your answer. You don't want to go in the right hand side basically. So let me show you the code. This is our code, as you can see, and this was the example I was telling. And for reference, like you can see this example also, k is equals to 3, which means third smallest value. If you look, this is the first smallest value, this is the second smallest, and the third smallest is here, and which is on the left hand side. So let me show you the code. It's same as just I wrote. So first we will have count equals to 0 and answer value to store the answer, and we'll call in order traversal. And as I said, why we are using in order is because while traversing in order, the values that we get, or it traverse the binary search tree in an ascending order manner, you can see. And for the first we'll go at the left, so we want to check the smallest value first. And while visiting that node, like first we went here at the leftmost value, left is null, right is null, left is null, we came back at the 1. Okay, and we'll increase the count, so first smallest value is being visited. And then before going right, we'll check if count is equals to k or not. No, it's not, because we have just traversed, or we have just seen the first smallest value. Then we'll come here, it came back to the parent, and count will increase to 2, because this is the second smallest value. And then we'll check if it is equals to k, or which is equals to 3. No, we'll check, go to the right, it's null. We'll come back, it will go to the parent, and like if you check for the like if we are at the 3, if you can't understand, you should suppose 3 as your root node, and like whatever you did here, that was your left traversal. Like let us suppose your root here is 3 and count is 2. Why? Because when first you went to the left side, you count the number of nodes on the left of this value. You have two, you have two smaller values than 3. Okay, and third will be the third smallest value. Okay, and before going on the right, you'll check if count equals to k. Yes, it is, as k equals to 3 and your count is also 3. So you will put it in the answer value and simply return. And let me just run it.